So we are continuing with our average rate of change handout, and after that Cynthia driving from LA to Stockton example, we're going to look at the general formula for average rate of change. So let f be any function whose domain includes the interval from a to b, that's an interval of x values. The average rate of change of the function f from x equals a to x equals b is given by the following formula. Now, I wrote delta y over delta x because it looks like a slope formula. And it is f of b minus f of a over b minus a. So the difference of output values divided by the difference of the corresponding input values. In an application, the units of average rate of change will always be output units per input units. In the Cynthia example, the units were always miles per hour. And note, from x equals a to x equals b means the same thing as on the interval ab. So often these words here are replaced with on the interval square bracket a comma b square bracket. That interval refers to an interval of x values. So in our example with Cynthia, again, the units of the average rate of change were miles per hour. I just said that a moment ago. And I just want to make one more comparison to that Cynthia example that we went on about. I'm going to pull just 1c, part 1c off of that, where we calculated the average speed from x equals 1 to x equals 3 hours. And this is the same calculation we went through where we took a difference of miles over a difference of hours and then divided, and we got 70 miles per hour for her average speed. So in general, we can call this the average rate of change of the function f. So that function f on the first page, that complicated looking function, on the interval, we'll say it's on the interval 1, 3 in square brackets. That refers to the input values of 3 hours and 1 hour. And if we use our new formula here for it, where this difference, 219 minus 79, is f of 3 minus f of 1 over 3 minus 1. That corresponds exactly to this f of b minus f of a over b minus a formula that we're seeing on the handout right here for the average rate of change of any function on the interval from a to b. So let's go ahead and apply this now to exercise 2. And I recopied exercise 2 on a separate sheet of paper. First, we're just given this function, so x squared minus 6x plus 4. And we want to find the average rate of change of f on the interval 0, 3. So that 0, 3, that's my a comma b, which means a is equal to 0, b is equal to 3. We want to calculate this f of b minus f of a over f of b minus f of a over b minus a quantity. So we need f of 0, which plugging into this function is 0 squared minus 6 times 0 plus 4, which is equal to 4. And we also need f of 3, which is 3 squared minus 6 times 3 plus 4 is 9 minus 18 plus 4. 9 minus 18 is negative 9 plus 4 is negative 5 is f of 3. So that what we call the average rate of change on the interval 0 to 3 is f of 3 minus f of 0 over 3 minus 0. And we just calculated f of 3 is negative 5 minus 4 over 3. That's negative 9 over 3, or negative 3. We'd say the average rate of change is negative 3. Here we have no units because we're just working with an abstract function. Let's go ahead and do part B. So we're working with the same function. Now we already have f of 3. I calculated up above f of 3 was equal to negative 5. We still need f of 6 here, so I've got to go to 6 squared minus 6 times 6 plus 4. That's 36 minus 36 plus 4. That's going to be just 4. So we got our f of 3 and we got our f of 6. So in part B, our AB interval is from 3 to 6. So the average rate of change on the interval from 3 to 6 is given by f of 6 minus f of 3 over 6 minus 3. And we got our f of 6 value is 4 minus the f of 3 value is negative 5. Notice how I have 4 minus a negative 5. There's a minus sign from the formula and a minus sign attached to f of 3 over 6 minus 3. 4 minus a negative 5 is 4 plus 5, or positive 9 over 3. So that's going to be equal to a positive 3. And that's the answer for B. So in A we got a negative. Sometimes average rate of change comes out to be negative, but in B we actually got a positive 3.